Hello, and welcome to Achieving Healthcare Interoperability with FHIR Works on AWS. My name is Stephen Johnson. I'm a solutions architect in the UK healthcare team. I've been working with the FHIR Works on AWS toolkit since its inception at AWS, contributing to its direction and advocating for customers who are using the toolkit. I'm joined today by Dr. Dunmail Hodkinson, CTO of Black Pear Software. He will introduce himself in greater detail later in the presentation and tell us all about what Black Pear Software are doing with FHIR Works and AWS. This session is a follow-on from another, more introductory session. The previous session included the fundamentals of the FHIR standard, the introduction to the FHIR Works and AWS toolkit, and some of the common use case categories for FHIR. In this session, we'll be covering the logical architecture of FHIR Works and AWS. Now, this will be illustrated through the use case categories from the introductory session, but don't worry if you haven't seen that. I'm going to explain that as I go through. I'll also move on to explaining how to get started with the toolkit, doing a deeper dive into the technical architecture that makes up the toolkit, and then handing over to Dunmail, who will explain how Black Pear are using FHIR Works and AWS. And then finally finishing off with some resources so you can go and explore more. Okay, on to the logical architecture, which shows some of the ways that this toolkit can be used. All right, so the first use case category is the standard FHIR server. This is the most basic use case for the FHIR Works and AWS toolkit, and it's what's deployed if you use the scripted deployment from our GitHub repository. On this diagram, on the left-hand side, you can see that there are FHIR clients interacting with the FHIR API. And these could be web, or these could be mobile, or maybe even another system. The first interaction is to authenticate, which can also be federated to an external IDP if needed. When authenticated, the next is the FHIR interface, which passes the payload through to the FHIR server logic. The server logic will perform validation, and it will dictate what happens with that payload. And the configuration for that is stored in the router config, which will include whether to store the FHIR payload in the persistent store or whether to route that request elsewhere. The diagram also shows the bulk data access export, which is a way of retrieving large amounts of data all at once from the FHIR server. Building on that, we have this second use case category, which is called data aggregation. So this is about building a basic FHIR server, but it also includes a means for bulk ingestion of data from multiple systems. The right-hand side shows existing medical systems of record, and then in between the dotted lines shows the integration framework. The integration framework is what enables third parties like you, the customer or the partner, to build transforms. These transforms would be responsible for retrieving the data from those systems, transforming that data into FHIR, and then sending the payload through to the FHIR server for validation and for persistence. The third use case category is data exchange, and this is also known as a facade deployment. And in this case, the FHIR server would route all the payloads through to various different backend systems via the integration framework. As mentioned previously, the configuration for this is within the router config. The integration framework, again, in this case, allows our customers, our partners, to develop their own transforms to integrate with those existing backend systems. For this, we provide advice and guidance on best practices for the transform execution environment, and these transforms can be as complex or as simple as required for the specific use case. This could be one-way or two-way for read-only or read-write deployments. And the integrations may include constructs such as a connectivity manager to handle connectivity to back-end systems, or a credentials mapping store, which is a very useful construct if the credentials used at the FHIR interface differ from those used at the back-end systems. So this construct can provide a mapping between those credentials. Okay, hopefully that has you excited. Now let's get into how to get started. The FHIR Works on AWS toolkit is open source and it's available from GitHub. It's really easy to get started. We have a scripted deployment in which you can deploy into your AWS account in around 30 minutes. And to get started, have a read at the GitHub repository. It'll cover off everything that we mentioned here. The QR code on screen now is for that, and you can either reach that via that method, or you can search your favorite search engine for the FHIR Works on AWS deployment GitHub page. You'll need a number of different things to get started, so let's go through those prerequisites. You'll need an AWS account, and it'll need to have the relevant IAM user permissions. You'll need a deployment machine that has enough memory. So if you don't have enough memory, you may get some deployments from the serverless framework, which we use for deployment. You'll also need some software installed, so this will really depend on what OS you're using. So if you're using your Linux or Mac, it's going to be AWS CLI. If you're using a Windows machine, you'll need Windows PowerShell for AWS. And also if you're using a Mac, you'll need Homebrew. So getting your hands on the code is really super easy. So you can go and you can clone a repository if you've got Git installed. If you don't, you can download it straight from the GitHub page. On there, we provide the manual instructions if you want to go down that route. They are for Mac OS, or you can use a scripted install, which is available for Linux, Mac OS, Windows, or even Docker if you want to use that. That scripted install uses a serverless framework, and all the instructions can be found on the GitHub repository. Okay, so let's say you were following the scripted installation and you want to, I will go through here the steps for the Linux or the Mac version, just to give you an example of just how easy it is. So to run the scripted deployment, you're going to need to configure AWS credentials, and to do this, you'll run AWS configure. Then you'll need to do another couple of commands as shown on here, which include changing the directory, making the script executable, and then running the script with the region and the stage parameters. For the regions, that would be your usual. That could be US-East-1 or EU-West-2, for example. And for the stage, that's just a string to label your deployment. Common things there would be dev, prod, or test. Okay. So once you've run the installation, go and have a look at the output. You'll find that from serverless, which will come up in your terminal, but you'll also find it from the CloudFormation output. So if you look through the console at the CloudFormation output, it's going to show you all of the AWS resources that have been deployed. To get up and running straight away, we include in the repository some Postman collections. So this means right from the get-go, you can go ahead and you can start posting queries to the FHIR API. So these include the / metadata, which will get you the capability statement from the server. And also we include sample queries for patient and binary endpoints for interactions such as to create, read, to do a versioned read or vread, to do update, to do delete, and also to search various different queries using different HTTP verbs. Okay, so let's dive deeper into the technical architecture. If you were to deploy from the scripted installation, you get everything as shown on the slide here. This is the reference implementation or the standard FHIR server. Walking through the workflow, you can see the users on the left-hand side who are using the FHIR applications. They have to first authenticate with Cognito. Then they make the request against the API gateway, either directly or through an external system, which would make the request on their behalf. The API gateway hands a request to Lambda, which holds the FHIR server's logic. All resources, with the exception of the binary resources, complete their creates, reads, updates, and delete interactions against DynamoDB. The workflow for binary resources is slightly different. In that case, a pre-signed S3 URL is generated and sent to the client for its interaction. Reads occur from the pre-signed S3 URL along with metadata from DynamoDB. Creates and updates will also use the pre-signed S3 URL, and following that, the associated metadata will be stored in DynamoDB. In all cases, changes to DynamoDB are streamed to Amazon Elasticsearch. Search interactions for all resources then occur against Amazon Elasticsearch. Okay, let's look at the makeup of FHIR Works in AWS. FHIR Works in AWS has been designed for flexibility, which suits customers and partnership builders. It's been made up of 6 different TypeScript packages. These are shown in the upper right of the screen. Each of the 6 packages have different concerns. And you can use all of these to get the reference deployment, or if you want to, you can pick and choose. You could even write your own. As this is an open source project, we encourage the community to contribute code. That might be to those reference packages, or maybe to new packages which integrate alternative technologies, such as different database types, for example. The first package, which is shown here, is the one that you get from the main FHIR Works on AWS GitHub page, and that's the deployment package, which is responsible for pulling down all the other packages and for deploying into your AWS account. Let's have a look at some of the other packages that fall within that. So we've got the interface package, which handles the configuration of the other packages. We have the authorization package, which deals with role-based access control. And we have the routing package, which holds the main FHIR server logic, which handles validation and the interactions with the persistence and the search packages. The persistence package handles operations with DynamoDB to store or to read FHIR data, and it deals with S3 for binary resources. The search package handles operations with Elasticsearch for search interactions. Okay, again, continuing to look at the technical architecture and then looking at another use case category. So moving on to a deployment which meets that. So this meets data aggregation. And this is a standard FHIR server along with the use of a third-party transform. In this case, AWS Glue is doing the bulk retrieval of medical data from an external system. It's transforming that into the FHIR standard and then storing it in DynamoDB. There are other ways to use integration framework as mentioned before. So let's have a look at the third use case category, and this is data exchange. Again, using a third-party transform created by the customer, this time as a microservice which FHIR Works on AWS will interact with. This could alternatively be achieved by creating your own packages for persistence and search if you need the maximum flexibility. But using the integration framework and building your own microservice in this way helps make it easier for you to use updated version of FHIR Works on AWS and including all the extra features that they bring. And all you have to do is maintain your own microservice code. In the case of this particular microservice, this is made up with API Gateway and with Lambda. Lambda suits short-lived interactions, so there are other ways to do this. Another example would be Fargate with an elastic load balancer as shown here. And this would be more suitable for external systems which need longer-lived connections, such as if you're handling HL7 v2 messages. Okay, so that's the technical architecture. Now I will hand over to Dunmil, who will introduce himself and explain how Black Pear Software use FHIR Works on AWS.
Thanks, Stephen. My name's Dunmil Hodkinson. By background, I'm actually a research biologist, but I've been building interoperable health information systems since before 2000. I'm currently the Chief Technology Officer at Black Pear Software. We're an SME working with the National Health Service in the United Kingdom. And I'm also the immediate past chair of HL7 UK. It's an affiliate of HL7, which is the international standards organisation that's responsible for a whole series of health interoperability standards, including HL7 FHIR. With Black Pear, we work with 2 distinct groups of customers. We work with health system providers, and we also work with app and service builders who want to use health record data. And what I'm going to talk about now is just about how Black Pear were able to adopt FHIR Works on AWS to help us meet the goals of our 2 groups of customers. At the moment, health apps and services are an exploding market. Shouldn't be a surprise because health affects everyone on the planet. And there are lots of app and service builders who want to use health record data to provide a richer, personalised experience for both clinicians and patients. This means that when a clinician, such as a paramedic, visits your home, they should be able to see information about your medical history, your current prescriptions and your allergies before they even walk through the door. And as a patient, I should be able to see my medical history, and I should be able to integrate it with a personal health record that is kept up to date from connected devices such as smartwatches, which might measure pulse rate and oxygen saturation. However, at the moment, we see much health data is inaccessible. It's locked into proprietary systems. It's hard to access. It's often shielded by an almost toxic mix of complex bureaucracy and legacy technology. But in spite of this, many health system providers want to share the data with partners so that patients can receive better care. And the first thing we'll talk about is how we've been able to help health system providers share their data using HL7 FHIR APIs. For many health system providers, the existing data structures that they've got mean that it's really not practical to use an off-the-shelf general purpose FHIR server like HAPI or FHIRly server. And they often need to go and use the adapter design pattern. This is where an adapter can convert one interface, that's the legacy interface to their existing system, into another interface that clients expect, a FHIR interface. So we see it in the UK. There are major general practice systems providing proprietary APIs to share their data. And these are based on a range of technologies that includes XML web services, it includes custom sockets. By using a FHIR adapter, we can present a common FHIR API onto all of these systems. And similarly, we see that we may want to create facades which provide a unified interface to a whole set of interfaces in the subsystem. Again, another example from the NHS, we see that for some data sources, we have to use, firstly, HL7v3, which is XML web services, to query one source, then look at the information using LDAP, and then finally use an HL7 FHIR REST API. That's quite complex, but by placing a facade in front of that, we can orchestrate those calls to provide a much better experience for the user of that system. So the key question if we want to build an adapter is, what do we actually have to do? The HL7 FHIR APIs are designed and built on internet standards. They're built on HTTP and REST. But it can still be intimidating and quite time consuming to implement the service from scratch. But what are the components you'd have to implement? First, you have to know about the standards. So the FHIR standard provides the shared specification. And that's built up from a number of parts. So there's the international FHIR standard. And that comes in multiple versions. We're now at what's called R4, release 4, with release 5 due soon. There's plenty of nuances and optionality within there, which can make it confusing for somebody. Layered on top of that, we also see that different domains, different countries will produce implementation guides describing how to use FHIR for their specific use cases and within their specific domains. There's a whole lot of complexity there that can be quite intimidating. In the actual software engineering, we need to provide a router module. That provides the common capability for a FHIR REST API. It's responsible for taking that FHIR request and routing it to other components, catching thrown errors, and ensuring that responses are returned in FHIR format. And in parallel to that, we need a set of simple interfaces which describe each of the FHIR API interactions, and that allows us to define a communication contract between the other components in our system. Both the router and interfaces are common to all FHIR servers. Everybody has to implement them. And that's allowed us to take the work done within FHIR Works on AWS. So we've been able to take the routing module and also the interface package and import those capabilities into our code so that we can deploy those into a Lambda function and we get those capabilities immediately. That saves us a huge amount of time. Finally, we've got the transformation in the source system. For each different source system, we'll need some sort of bespoke code to convert data from a native format into the FHIR format and vice versa. And these source systems can have all sorts of different architectures. They might use a relational database and provide a SQL interface. maybe a document database, maybe an XML web services interface. So transforms are a key component. It'd be great if FHIR Works on AWS could solve this problem for us, but it can't. That's the piece that we have to work on. But by using FHIR Works to provide the common capabilities that we need, we can focus on where we can provide the most value to our customers. We're using our experience, our understanding of health informatics, to work with them to provide reliable and safe transforms to their legacy data. So what does one of these transforms actually have to look like? So I've created a hypothetical case here where we're looking for patient resources in a health system which contains patients stored in a SQL database. And this module shows how you might implement a search interface based on the FHIR Works on AWS interface package. If the request is looking to search for another type of resource, such as medication, you can see that we simply throw an error and we allow the router to respond in a FHIR compliant way. It's as simple as that. We don't have to worry about the semantics of how you respond to errors in FHIR. If we're on our happy path and the search is for a patient, we might create code which will transform the FHIR request into a SQL query. We can execute the SQL query asynchronously against a database. And then for each record that's returned from the database, we'll map it onto a FHIR resource. And we can use whatever technology we prefer. We may use code. We may use a templating engine such as handlebars. We might use FHIR mapping language. Once we've got those FHIR resources, we can return them from our method, and the router itself will then respond in a FHIR compliant way. We've taken a lot of the work away. How does that map onto the technical architecture? What we have is we create an adapter that encapsulates the transform for a specific source health system. From FHIR Works on AWS, we can pull in interface and routing packages, and then we deploy that in an architecture that's very similar to those that we've already seen. We have the adapter package, which provides the transformation, and we can swap out different adapter packages for different source systems. We use Amazon API Gateway to provide the REST endpoint, and we can use custom authorizers so that our customers can choose to use different identity providers depending on their use case. And all in all, this allows our customers who provide health systems to quickly create FHIR APIs so that they can share their data. Creating the API is only part of the battle. Somebody actually has to use it. And we learned very early on that apps and service builders want to focus on adding great features and great capabilities. So when they consume an API, they don't want to spend lots of time setting up connections, learning new technology. So we've automated deployment of new API endpoints using a management console to trigger cloud formation deployments. We're able to provide that as a service called QuickFire. That helps our customers. So those people who are app and service builders can quickly start using FHIR APIs. They can choose an off-the-shelf FHIR API for a system that they want to connect to. They can launch it through AWS Marketplace. They can customize that API to their needs by choosing from pre-configured web application firewalls. They can choose the authorizer function they want to use. They can choose how logs and audit events are saved. Once they've customized it, it's stood up and they can start using the endpoint. They can start using the API straight away. That really allows us to make it faster and easier for both the health system providers to implement FHIR APIs and make them available on the fault-tolerant, scalable infrastructure that we can get from AWS Cloud. And also to make it faster and easier for the app and service builders who want to consume health data to be able to actually get those APIs up and running and start using them. Our experience is that we reduced our time to build and deploy a simple adapter from what was a few weeks to now just a few days. And at the same time, we've been able to switch our deployment model from using a fleet of EC2 instances to a completely serverless deployment. These FHIR APIs are now available for builders to use from within health apps and services so they can provide that richer, personalized experience for both clinicians and patients that we want to support them to offer. Ultimately, that takes us closer to our goal as a company of providing technology solutions that have the capability to underpin a better global health system. So thanks very much for your time today. I'll hand you back for Stephen to share more information about how you can get involved and how you can use FHIR Works on AWS.
Thank you, Domel. To wrap up, I'm now going to cover off some resources. So perhaps you want to create your own TypeScript package and you want to share that with the community, or maybe you want to develop and you want to contribute to the FHIR Works and AWS reference packages. Well, to do that, please interact with us via GitHub. Please see the documentation that's on there, specifically development.md and contributing.md. To contribute code, create pull requests, to submit feature requests or report bugs, create GitHub issues on the repository. Here's a number of different links. First, the release blog for FHIR Works and AWS, and also a link to the GitHub repository in case you missed that from earlier. Also, if you want to know more about Black Pear Software or around QuickFire, please see the links at the bottom of the slide. At this point, I'd like to also mention that we have several other healthcare sessions being offered. These topics range from healthcare executive outlook to using AI to automate clinical workflows, just to name a few. So please take some time to review all of our other sessions and join those that are of interest to you. I'd like to thank you very much. And lastly, please complete the survey, the session survey. We really appreciate your feedback. It really helps us improve.